In 2013, a significant event occurred when a space rock impacted the Earth's atmosphere near Chelyabinsk, Russia. The meteor produced a brilliant flash in the sky followed by a loud explosion, sending shockwaves that shattered windows and injured nearly 1,500 people. This was no ordinary occurrence. The explosion was caused by a 66-foot-wide meteor traveling at an astounding speed of 19 kilometers per second, about 42,699 miles per hour. The energy released was equivalent to 500 kilotons of TNT, over 30 times more powerful than the Hiroshima nuclear bomb. Fortunately, the meteor exploded high in the atmosphere, sparing the Earth from the full force of the impact. However, the shockwave still caused significant damage, destroying 7,200 buildings across 6 cities. This event serves as a reminder of the potential danger posed by space rocks. While smaller meteors are a frequent occurrence, it's the larger asteroids like the one known as Apophis 99942 that truly pose a grave threat. Apophis, a massive asteroid about 1,100 feet wide, is currently on track to fly close to Earth in 2029, sparking concern among scientists. Initially, there was a 2.7% chance it could collide with Earth in 2029, but further research has ruled out that possibility. However, the asteroid could still pass through a gravitational keyhole, a small area in space where a planet's gravity could alter its trajectory. If Apophis were to pass through this keyhole, the collision would likely occur in 2036, with a devastating impact on Earth. Neil deGrasse Tyson has raised alarms about the potential consequences of a collision, describing a scenario where the asteroid impacts the ocean, triggering massive tsunamis that could devastate the western coast of North America. If Apophis were to strike, the impact would cause a massive explosion, creating a crater 3 miles wide, and the resulting shockwaves could wipe out entire regions. While the chances of such a catastrophic event are slim, the prospect of an asteroid collision is something that keeps scientists on edge. Every day, Earth is bombarded by smaller space rocks, and scientists continue to monitor the skies for any potential threats. The Chelyabinsk event, though smaller in scale, serves as a stark reminder of the power these objects can hold. If something as large as Apophis were to collide with Earth, the consequences would be far more devastating, and humanity's survival could be at risk. The significance of advancing our recognition and observation efforts to identify potentially hazardous asteroids before they become a threat cannot be overstated. NASA and other space agencies worldwide are actively engaged in asteroid detection and mitigation initiatives. Programs like the Near-Earth Object Survey Mission, NEOSM, and the NEO Assessor spacecraft aim to improve our ability to detect and characterize asteroids, particularly those that pose a risk of colliding with Earth. Once an asteroid is identified and its orbit is determined, scientists can assess the likelihood of an impact and develop mitigation strategies if necessary. These strategies range from methods like kinetic impactors or gravity tractor devices to more speculative techniques, such as nuclear explosions, which could alter the asteroid's trajectory. The planetary defense community also emphasizes the importance of international cooperation in addressing the asteroid threat. Collaborative efforts pool resources, expertise, and knowledge, which are critical in enhancing our collective ability to detect, track, and mitigate potentially hazardous asteroids. In addition to their potential dangers, asteroids offer significant scientific insights. Studying their composition can shed light on the early formation and evolution of the solar system. Some asteroids are believed to contain valuable resources, such as metals and water, making them potential targets for future space exploration and resource utilization missions. Furthermore, asteroids have played a critical role in shaping the development of life on Earth. Impact events, such as the one that led to the extinction of the dinosaurs, are thought to have been caused by asteroid collisions. Alternatively, these impacts may have also delivered essential organic materials and water to Earth, potentially fostering the conditions necessary for life to evolve. Asteroid research is inherently interdisciplinary, combining fields like astronomy, planetary science, geology, and aerospace engineering. Advances in technology, such as high-resolution imaging and spectroscopy, have revolutionized our understanding of these celestial bodies and continue to drive new discoveries. Beyond their scientific and existential significance, asteroids capture the public's imagination, often featuring in sci-fi movies and documentaries, reflecting our fascination with the universe and our desire to understand our place within it. Looking ahead, asteroid research faces several challenges and opportunities. Continued investment in observational capabilities, computational modeling, and international collaboration will be crucial in advancing our understanding of asteroids and improving our ability to predict and mitigate potential impact events. Education and public outreach also play vital roles in raising awareness about the asteroid threat and the importance of planetary defense. By fostering public support for funding and initiatives aimed at protecting Earth from future asteroid impacts, we can enhance our preparedness. In conclusion, asteroids are ancient remnants of our solar system's formation that continue to intrigue and challenge scientists and space agencies alike. While most asteroids pose no immediate threat to Earth, the potential consequences of a collision with a large asteroid underscore the importance of ongoing research and preparedness efforts. By studying asteroids, we gain valuable insights into the history and evolution of our solar system while also developing strategies to protect our planet. Through collaboration, innovation, and public engagement, we can strengthen our ability to detect, track, and mitigate the asteroid threat, ensuring the safety and resilience of humanity in the face of cosmic hazards. The chilling aspect of the Chabin incident lies in how subtly it unfolded, catching everyone off guard. The space rock remained undetected until it entered Earth's atmosphere, largely due to its trajectory being obscured by the sun's brilliant glare. Interestingly, on the very same day, the Planetary Society had organized an online class to discuss asteroid 367944 DEND, a 98-ton space rock predicted to make a close pass by Earth. It was discovered by a winner of the Planetary Society's Shoemaker Award, which supports upgrades to observatories. This asteroid represented an important moment for both Society members and the public. Beyond funding asteroid research, the Society's mission includes raising awareness about asteroid risks and advocating for government funding to improve both ground and space-based asteroid detection systems. Thanks to advancements in asteroid detection technologies, such as the NEO, Near-Earth Object Assessor mission, our ability to identify and track asteroids like DEND has greatly improved. Equipped with such tools, we can now predict their trajectories early, allowing for proactive measures to reduce potential dangers and protect lives. Ideally, this means asteroids like the Chabin meteor will be detected long before they impact Earth's atmosphere. It's important to note that the Chabin meteor only entered Earth's upper atmosphere and did not reach the ground, as it exploded in the air. In contrast, asteroid Apophis is expected to potentially strike Earth's surface, which could cause catastrophic damage. However, these predictions are based on old estimates, and significant advancements have been made in asteroid detection since then. So, let's look at the latest updates to determine whether Apophis will really impact Earth or if we'll remain safe. When Apophis was first discovered in 2004, early assessments deemed it a dangerous asteroid with Earth-threatening potential. However, subsequent observations refined its orbit, reducing earlier fears. The likelihood of Apophis passing through a gravitational keyhole, a potential trigger for a collision, has significantly decreased. With updated measurements, its size is now estimated to be less than 600 meters, making an impact scenario highly unlikely. Initially, Apophis was thought to be 600 miles wide, but recent data has corrected this to around 600 meters. Early calculations suggested a 3% chance of Apophis colliding with Earth on April 13, 2029, sparking widespread alarm. However, reassessments based on more precise observations have greatly alleviated those concerns. This first occurred in 2006 when researchers predicted that Apophis's orbit would pass through a narrow gravitational keyhole. This shift pushed the potential impact date to April 13, 2036, easing fears. In 2008, NASA's further analysis reduced the likelihood of a 2036 impact to 1 in 45,000, a significant decrease. A decade later, the European Space Agency recalibrated this estimate to 1 in 150,000. Despite these reassuring projections, vigilance remains critical. Earth is constantly at risk from asteroids like Apophis. Advanced tools, including ground-based observatories and space telescopes, are crucial for early detection and mitigation strategies. Understanding the dynamics of near-Earth objects, NEOs, like Apophis, is essential for developing effective countermeasures. This involves continuously monitoring their orbits, predicting possible keyholes, and creating diversion methods to protect our planet. Furthermore, global collaboration among space agencies, scientists and policymakers is vital for pooling resources and information to address the asteroid threat. Asteroids, often referred to as minor planets, are rocky bodies that orbit the Sun, mostly found in the asteroid belt between Mars and Jupiter. They vary widely in size, from small rocky fragments to much larger bodies hundreds of kilometers across. These celestial objects are remnants of the early solar system, left over from the process of planetary formation over 4.6 billion years ago. Studying asteroids is crucial not only for understanding the history and composition of our solar system but also for assessing potential risks to Earth. These objects can pose significant threats if their orbits intersect with Earth's path, potentially leading to catastrophic impacts similar to the Chelyabinsk event in 2013. One of the main challenges in dealing with asteroids is their detection. While larger asteroids can be tracked using ground-based observatories and space telescopes, smaller ones often go undetected until they enter Earth's atmosphere.